All right, we have another video on factoring. So factoring continued for these notes, and I mentioned it the first time in the video that I talked about GCF, but I said all the factoring problems we can do, we really should be checking for a GCF first, or I mentioned that GCF would come into play later. And so this is the video where I'm going to show you guys that yes, we could have a GCF in every single factoring problem that we do. So all of these examples are going to have a GCF in them. So first we're going to do a problem with just the GCF, just to make sure, kind of to warm up our brains to this video, I guess. So for this one, we're going to do 4r squared plus 36r. So I'm looking for the number that's in common between 4 and 36. I can see that 4 divides into both of those numbers, so I'll go ahead and take out the 4. If I look at the variables, I have an r squared, I have an r over here to the first power, so I'll take out the r. And so then when I look at my terms, 4 divided by 4 is 1. You can write the 1 or not write the 1, it's fine. From the r squared, I have 2 r's. I took out one of them. That means that I have 1 left over. Then with the 36 divided by 4 is 9. I have 1 r over here. I took 1 r out, and so I'm finished. Right? Next, let's go ahead and factor a trinomial. So I've got 2n squared minus 10n minus 28. So with this problem, it might seem like it's a slide divide problem to start with, but then if you look closer, you'll notice that you do have a GCF. So if you look at the numbers, you can see that every single term is a factor of 2. They're all even numbers. 2n squared, 10, and 28. So what we're going to do first is we're going to take out a GCF of 2, and then we're going to see if it's still a slide divide problem or if it became one of the more simple trinomials. So I'm going to take out the GCF of 2, and then between the other part, the variable, I can look, I see an n squared and an n, but over here there's no n, so that means that I'll just take out the 2 as the GCF and no variable. So it leaves me with an n squared. 10 divided by 2 is 5, leave the n. 28 divided by 2 is 14. And so now if I look at my leftovers, I can see that the n squared is all alone, and so that means this is one of those more simple trinomial problems. It is not a slide divide problem. So here I'm going to go ahead and I'm just going to look for two numbers that multiply to negative 14 but add to negative 5. So two numbers that multiply to negative 14 but add to negative 5, negative 7 and positive 2. So I'm going to keep the GCF in the front, and then I've got n minus 7, n plus 2. Okay, let's try another one like that. So for this one, we'll go ahead and do some bigger numbers. 6x squared plus 42x minus 108. So on this one, the 6 in the front, that could be a GCF, or it could be that this is just a slide divide problem. So whenever I see a number in the front, I'm now always going to check to see if that's a GCF. So I'm going to look, 6, does that divide into 42? Yes. Does that divide into 108? I'm not sure, so I'll go ahead and check. 108 divided by 6, okay, yes, it's 18. So I'm going to go ahead and take out the GCF of 6. And there's an x squared and an x, but no x over here. So that means that the variable is not a GCF. And so when I take out that 6, that leaves me with x squared. 42 divided by 6 is 7x. And then we just saw that 108 divided by 6 was 18. So now I can go ahead and do that process for the simple trinomials. I'm looking for two numbers that multiply to negative 18 and add to 7. And the two numbers that do that are 9 and negative 2. So I've got 6, x plus 9, and x minus 2. right? For the next one, we're going to go ahead and do 5x squared minus 80. So this one is not a trinomial, this is a binomial. And whenever we have just two terms like this, you might look at the first problem and think, oh, it could just be a GCF like the first problem was. This was just simple. So I would start by looking and taking out a GCF, but when you're finished with the problem, you should also consider, could it be a difference of squares problem? So when I look at this, I see I've got a 5 here, an x squared, and then over here, I don't have an x at all. So I'm going to think, does 80 divide by 5? And the answer is yes. So I'll write the 5, I'm going to take that out. That gives me x squared. 80 divided by 5, 16. And so this is one of those difference of squares problems because I have an x squared and I have 16, which is a perfect square. So this was one of those problems where you have two sets of parentheses, one with a plus, one with a minus. So we say x squared is going to be x multiplied by x, and 16 is going to be 4 multiplied by 4. So we have x plus 4, x minus 4. Okay. Couple more here. Sorry, my lead broke. Okay. So next we've got 28n squared minus 220n minus 32. Okay, so with this one, we've got some really big numbers here, specifically the 220, so I'm going to ignore that one. I'm going to think about the 28 and the 32. 28 is not the GCF because you can't take 32 and divide it by 28 and get a whole number. So this is one where I'm going to look for a number that divides into 28. I'm going to look for a number that divides into 32. And then I'm just going to double check and make sure that number divides into 220. So 28 and 32, when I think of 28, I think of 4 times 7. And when I think of 32, I think of 4 times 8. I think there's more numbers that multiply to 32, but I'll double check and see if 220 divides by 4. Yep, so I think that that's probably it. So I'm going to take out a GCF of 4. That leaves me with 7n squared minus 55n minus 8. So 28 divided by 4 is 7. Kept the n squared. 220 divided by 4 is 55. Kept the minus. 32 divided by 4 is 8. So now that I've written this, I still have a number in front of the n squared. And that number 7, that's not a GCF. It's still there. That means that this is a slide, divide, bottoms up problem. So slide, divide, bottoms up. I'm just writing the steps so that I remember them. Okay, so my first step is going to be to slide the 7 over to the negative 8. So 7 times negative 8 is negative 56. So I'm looking for two numbers that multiply to negative 56 but add to negative 55. And the two numbers that do that are negative 56 and positive 1. So I have n minus 56. N plus 1, okay? Now, the number that I slid, the 7, the number that I slid is now going to be the number I'm dividing by. So I'm going to divide by 7 and divide by 7. And I have to be careful. I almost forgot it. That GCF of 4, I can't forget that. I have to keep that in the problem. So I'm going to go ahead and take that GCF of 4 and I'm going to write it right here. Okay, so I slid the 7 over in the beginning of the problem. I multiplied it over. Now I'm going to divide by 7, divide by 7. So I've got that step. Now I'm going to think about, with these two fractions, can they be simplified at all? So 56 divided by 7, that divides evenly. So 56 over 7 is 8. And then for this other one, 1 over 7, that does not reduce. It doesn't simplify. And so that means for that piece, we're going to have to do bottoms up. And so that leaves me with 7n plus 1. And then over here, I have to take the GCF and move that to the front. And so there we have it. There's our factors. Okay, we're going to do one last example. And then you guys will be ready to practice in class. Okay, so this one, the numbers are a little bit smaller. So 18n squared plus 36n plus 16. Okay, so you could ignore the 36 if you want and just focus on the 18 and the 16 to find the GCF, or you could look at all three of them together. When I first looked at the 18, I thought, okay, maybe it would be 3, maybe it would be 6, maybe it would be 9. But then when I looked at the 16, a lot of those numbers don't go into 16. And so then I realized maybe it's just the fact that they're even. So 9 goes into 18, 9 goes into 36, but it doesn't go into 16. 6 goes into 18 and 36, but not 16. 3 goes into both of those, but not 16. I think 2. 8 goes into 16. But not 36, I think it's 2. I think the GCF is 2. So I'm going to start by putting the GCF of 2 there. 18 divided by 2 is 9. And then 36 divided by 2 is 18. And then 16 divided by 2 is 8. Okay, so there is still a number left in front of the n squared term, and so that means we have to do slide divide bottoms up. All right, so I'm going to take the 9 and slide it over to the 8. 9 multiplied by 8 is 72. So I'm looking for two numbers that multiply to 72 but add to 18. And the two numbers that do that would be not 9 and 8. I think I need help with this one. 9 times 8 is 72. 72 divided by x. 6 and 12. I didn't know those off the top of my head. Okay, 6 and 12. So my two parentheses are going to be n plus 6 and n plus 12. Okay? So the number that we slid, and we need our 2. We need our GCF of 2. Okay. The number that we slid to make that happen was a 9, so now I have to go divide by 9, divide by 9. Okay, so we did the divide. Now we need to reduce our fractions, and we can reduce both of them. So 6 over 9, both of those numbers can be divided by 3. So 6 divided by 3 is 2, 9 divided by 3 is 3. Over here, both of these numbers can be divided by 3. So 12 divided by 3 is 4. 9 divided by 3 is 3. And now we can go ahead and bottoms up both of the fractions. So 2 in the front, 3n plus 2, 3n plus 4. There we go. All done.